Hello everyone, welcome back to my channel. This is the continuation part of hyperbolic function, and today we will learn some more important identities of hyperbolic function. So the first one is, consider that if x and y are belongs to R. Here I am writing, if x and y belongs to R, then we will have some identities that are, the first one is cos hyperbolic x plus sin hyperbolic x, which is equals to e to the power of x. Similarly, if there is cos hyperbolic x minus of sin hyperbolic x is equals to e to the power of minus x. So let's prove this one. As we know, the cos hyperbolic x formula is e to the power of x plus e to the power of minus x by 2. Then the sin hyperbolic x formula is e to the power of x minus of e to the power of minus x by 2. So we are taking this LHS side to get the RHS side, that is e to the power of x. Now on solving this, we get the LCM will be 2 and e to the power of x plus e to the power of minus x plus e to the power of x minus of e to the power of minus x. If you see here, these two values gets cancelled out and the only left out value is 2 e to the power of x by 2. So the value is e to the power of x. Now let's solve this one the same way only. Here we have to write the formula, only the sign changes here, by 2 minus e to the power of x minus of e to the power minus x by 2 upon 2. So on solving, we get e to the power of x plus e to the power of minus x minus e to the power of x minus minus is plus e to the power of minus x. So here minus of e to the power of x will get cancelled out and the remaining one is 2 e to the power of minus x by 2, which is equals to e to the power of minus x. So these are the two important identities of hyperbolic function. The next one we will learn and we will prove that identity also. So let's go for the next one. So the second one is cos hyperbolic square x minus sin hyperbolic square x, which is equals to 1. So this identity can be written as, there are two ways we can write it as, that is 1 plus sin hyperbolic square x, which is equals to cos hyperbolic square x. Similarly, the other one is cos hyperbolic square x minus 1, which is equals to sin hyperbolic square x. Kindly remember this formula. We get another two formulas from this. So let's solve this one. As we know the cos hyperbolic x formula, so we can write this one as cos hyperbolic x whole square minus sin hyperbolic x whole square. So here we know the formula of cos hyperbolic x, that is e to the power of x plus e to the power of minus x by 2 whole square minus e to the power of x minus e to the power of minus x by 2 whole square. Now we know 1 by 2 square, which is equals to 1 by 4. So here 1 by 4, since I will follow the formula called a plus b whole square minus of a minus b whole square, so that we can write it as 4ab. So now 1 by 4 e to the power of x plus e to the power of minus x whole square minus 1 by 4 e to the power of x minus e to the power of minus x whole square. Now on solving we get 1 by 4. Since we are taking the common terms, we get 4. So this is our a value and this is our b value. So 4ab. So e to the power of x into e to the power of minus x. So observe this one. This is a value and this is b value, which is e to the power of x and e to the power of minus x values. Then on solving this, we get, on cancel outing the 4, then we get e to the power of x into e to the power of minus x, which is equals to, we can write it as e to the power of x minus x. So here we get the value as e to the power of 0, which is nothing but 1. So this is one more identity we learned from the hyperbolic function and also derived the formula. Now we will go for the next formula, that is similar one, sec hyperbolic square x, which is equals to 1 minus tan hyperbolic square x. Now I can write this formula as in the two forms, that is sec hyperbolic square x plus tan hyperbolic square x is equals to 1. And also there is one more formula, which is sec hyperbolic square x is equals to 1 plus tan hyperbolic square x. So I can write this one as sec hyperbolic square x plus tan hyperbolic square x, which is equals to 1. Now as we have done before, let's take the square outside. Sec hyperbolic x whole square plus tan hyperbolic x whole square. So we are solving from left hand side to get the right hand side value, that is 1. Now put the formula of sec hyperbolic x, or else we can follow the trigonometric function, that is sec theta is equals to 1 upon cos theta. In the same way for tan theta, which is equals to sin theta upon cos theta. Since I am following this formula because the denominator values are same, so we can get the value of 1. Now just write the values. 1 upon cos theta whole square, cos hyperbolic x whole square, then plus sin hyperbolic x upon cos hyperbolic x whole square. Now if you see here, we can multiply the square inside, that is 1 upon cos hyperbolic square x plus sin hyperbolic square x upon cos hyperbolic square x. Since here the denominators are same, we can write this value as 1 plus sin hyperbolic square x by cos hyperbolic square x. As we know the formula which I have written here, so 1 plus sin hyperbolic square x, which is equals to cos hyperbolic square x. So I can write this one as, which is equals to cos hyperbolic square x upon cos hyperbolic square x, which is equals to 1. So we got the value of right hand side, which is 1. So this is one more hyperbolic functions identity. Then the next one is given. The next one is cosec hyperbolic square x, which is equals to coth hyperbolic square x coth hyperbolic square x minus 1. Okay, Now we will solve this one by taking this one other side. That means we will solve from the right hand side, as we can write this one as cot hyperbolic square x minus cos cosec hyperbolic square x, which is equals to 1. So in the same way I will write it here so that we can prove the other side value. That means cot hyperbolic square x. Now take this cosec hyperbolic square x to the right hand side, so it becomes negative cosec hyperbolic square x, and the negative one, when it changes to the left hand side, the sign will be positive. Now in the same way we will follow the, as we have done in the previous identity, we will do the same. That is cot theta, which is equals to cos theta by sin theta. So cot theta value we can take by the trigonometric identity is cos theta by sin theta. Similarly, for cosec theta, we can write this one as the reciprocal of sin theta. Now just substitute the values. So there is other way we can write for this one is, which is nothing but taking this right hand side value to the other side. That means here I am writing the other term, that is cosec hyperbolic square x minus cot hyperbolic square x is equals to minus 1. So we can solve this one by using any of these one. So I'm trying with this, so which is equals to cot hyperbolic square x, which is nothing but cos hyperbolic square x upon sin hyperbolic square x. Since this one is in terms of square, so I have written this formula minus 1 by sin hyperbolic square x. So on solving we get cos hyperbolic square x minus 1 upon sin hyperbolic square x. So if you see here, I have written in the first identity the value of cos hyperbolic square x minus 1 is equals to sin hyperbolic square x. So here sin hyperbolic square x by sin hyperbolic square x, which is equals to 1. Okay, so we got the value. So this is what we have solved. This is the identity of the hyperbolic function. Now we will discuss some more identities of hyperbolic function. Here we go with some more identities. That is, excuse me, the fifth one is, if sin hyperbolic x which is minus x is equals to minus of sin hyperbolic x. So we will solve this one. As we know, the sin hyperbolic x formula is e to the power of x minus of e to the power of minus x by 2. So when it is in the minus x form, we can write sin hyperbolic minus x is equals to, we are just replacing the x term x term by minus x. So e to the power of minus x minus of, we know, minus of minus x, which is nothing but x. So here we got x upon 2. So by taking the negative value outside, we can write it as e to the power of x minus of e to the power of minus x by 2. So this is our sin minus sin hyperbolic x. If you see this one, this is our sin hyperbolic x value. So sin hyperbolic minus x is equals to minus of sin hyperbolic x. Similarly, the other one is cos hyperbolic minus x is equals to cos hyperbolic x. The same way we have to follow this to solve this one. As we know the cos hyperbolic x formula, which is nothing but e to the power of x plus e to the power of minus x by 2. So here it is given in the negative form. So cos hyperbolic minus of x, which is equals to e to the power of minus x plus e to the power of minus x upon 2. So this will be e to the power of minus x plus e to the power of x by 2. If you take the negative value outside, then this will be e to the power of x plus e to the power of minus x upon 2. So this is our cos hyperbolic x formula. So minus cos hyperbolic x. So this is one more identity of hyperbolic function, and the previous one is this one. Now the last one is tan hyperbolic minus x, which is equals to minus of tan hyperbolic x. So let's solve this one. So for this we know tan theta is equals to sin theta by cos theta. In the same way, when we follow to write this one, so tan hyperbolic minus x is equals to sin hyperbolic minus x upon cos hyperbolic minus x. So to take this one, we take to write the minus tan hyperbolic x, we have to take the negative value, so we can write it as sin hyperbolic x upon cos hyperbolic x, which is equals to minus of, so this one is nothing but our tan hyperbolic x formula. So this is one more identity of the hyperbolic function. There are some more identities, but we will discuss in the other video. So that's it for today. Thank you.